You can use the main log meter base if you stay under the sum of the non-continuous loads and 125% of the continuous load, as per National Electrical Code section 230.42 AON. In the scenario we are addressing, the sum of the non-continuous loads is 600 amps, calculated from 3 200 amp disconnects. The continuous load was not specified, so we will assume it to be 100 amps, represented by the 100 amp disconnect. Consequently, 125% of the continuous load would amount to 125 amps. Therefore, the total allowable load is the sum of the non-continuous load and the calculated continuous load, which in this case is 600 amps plus 125 amps, equaling 725 amps. Provided that the total load remains under 725 amps in your meter base, a main lug meter base can be implemented instead of a 600 amp main breaker. This determination hinges on understanding and applying the load calculation principles outlined in the National Electrical Code, specifically concerning continuous and non-continuous loads. When dealing with electrical installations, it's crucial to differentiate between continuous and non-continuous loads to ensure safety and code compliance. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. Non-continuous loads, on the other hand, are those where the maximum current is not expected to persist for extended durations. The National Electrical Code provides guidelines for calculating the allowable load on conductors and overcurrent protection devices, taking into account the nature of the loads. For service conductors, section 230.42 AON outlines the requirements for determining the ampacity of service entrance conductors. This section mandates that the service conductors shall have an ampacity not less than the sum of the non-continuous loads plus 125% of the continuous loads. This calculation ensures that the service conductors are adequately sized to handle the expected load, accounting for both continuous and non-continuous demands. In the presented scenario, the determination of whether a main lug meter base can be used in place of a 600 amp main breaker hinges on comparing the total calculated load to the ampacity of the main lug meter base. If the total calculated load, which includes the sum of the non-continuous loads and 125% of the continuous loads, remains below the ampacity rating of the main lug meter base, then it is permissible to use the main lug meter base. However, if the total calculated load exceeds the ampacity rating of the main lug meter base, then a 600 amp main breaker or a meter base with a higher ampacity rating would be required. It's important to note that the continuous load must be accurately determined to ensure the proper application of the 125% factor. Underestimating the continuous load can lead to undersized service conductors and potential overloading, which can create a fire hazard. Conversely, overestimating the continuous load can result in oversized service conductors and unnecessary expense. The determination of continuous versus non-continuous loads should be based on a thorough understanding of the expected load characteristics and the nature of the equipment being served. For example, lighting circuits, heating systems, and air conditioning systems are typically considered continuous loads, while receptacle circuits and motor loads may be considered non-continuous loads. It is also essential to consider any applicable demand factors that may reduce the overall load calculation. Demand factors are multipliers that are applied to the connected load to account for the fact that not all loads will be operating simultaneously at their maximum demand. Demand factors are typically based on historical data and statistical analysis of load profiles. The National Electrical Code provides demand factors for various types of loads, which can be used to reduce the overall load calculation and potentially allow for smaller service conductors and overcurrent protection devices. In summary, the decision to use a main lug meter base instead of a 600 amp main breaker depends on a careful calculation of the total load, including the sum of the non-continuous loads and 125% of the continuous loads. The total calculated load must remain below the ampacity rating of the main lug meter base. Accurate determination of continuous versus non-continuous loads and consideration of applicable demand factors are crucial for ensuring code compliance and safe operation of the electrical system. Always consult the National Electrical Code and local electrical codes for specific requirements and guidance. Consulting with a qualified electrical professional is highly recommended for complex electrical installations or when there is uncertainty about the proper application of the electrical codes. Understanding the nuances of continuous and non-continuous loads is fundamental to safe and efficient electrical system design. The National Electrical Code provides detailed guidance on how to properly account for these loads, ensuring that electrical systems are adequately sized to handle the demands placed upon them. Ignoring these requirements can lead to dangerous conditions, including overheating, equipment failure, and even fires. The 125% factor applied to continuous loads is intended to provide a safety margin to account for the sustained nature of these loads. Continuous loads generate heat over extended periods, which can degrade the insulation of conductors and other electrical components. By increasing the ampacity of the conductors and overcurrent protection devices by 25%, the risk of overheating is reduced. In addition to the 125% factor, the National Electrical Code also specifies derating factors that must be applied to conductors based on their ambient temperature and the number of conductors bundled together. These derating factors further reduce the ampacity of conductors to account for the effects of heat buildup. It is essential to apply all applicable derating factors to ensure that conductors are not overloaded. Overloading conductors can lead to premature failure and create a fire hazard. The proper selection of overcurrent protection devices is also critical for protecting electrical systems from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. The overcurrent protection device must be sized to protect the conductors it serves, taking into account the ampacity of the conductors and any applicable derating factors. It is important to select overcurrent protection devices with the correct interrupting rating. The interrupting rating is the maximum amount of fault current that the device can safely interrupt. If the available fault current exceeds the interrupting rating of the overcurrent protection device, the device may fail to interrupt the current, which can result in equipment damage and personal injury. The National Electrical Code provides guidance on how to determine the available fault current at various points in an electrical system. The calculation of fault current is complex and requires specialized knowledge. Consulting with a qualified electrical professional is highly recommended when determining the available fault current. In addition to the requirements for service conductors, the National Electrical Code also contains requirements for feeder conductors and branch circuit conductors. Feeder conductors are those that supply power from the service entrance to a panel board or subpanel. Branch circuit conductors are those that supply power from a panel board or subpanel to individual loads. The requirements for feeder conductors and branch circuit conductors are similar to those for service conductors, but there are some differences. For example, branch circuit conductors are typically protected by smaller overcurrent protection devices than service conductors or feeder conductors. The size of the overcurrent protection device for a branch circuit is determined by the ampacity of the branch circuit conductors and the type of load being served. The National Electrical Code provides tables that list the allowable ampacities of various types of conductors. These tables take into account the type of conductor, the insulation material, the ambient temperature, and the number of conductors bundled together. It is essential to consult these tables when selecting conductors for electrical installations. In summary, the design and installation of electrical systems require a thorough understanding of the National Electrical Code and other applicable codes and standards. Proper load calculations, conductor sizing, and overcurrent protection are essential for ensuring the safety and reliability of electrical systems. Consulting with a qualified electrical professional is highly recommended for all electrical installations. A qualified electrical professional can ensure that the electrical system is designed and installed in accordance with all applicable codes and standards, and that it is safe and reliable. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional before undertaking any electrical work. Remember that electrical work can be dangerous and should only be performed by qualified individuals. If you are not qualified to perform electrical work, do not attempt to do so. Contact a qualified electrical professional to perform the work for you. Safety should always be the top priority when working with electricity. Always follow safe work practices and use appropriate personal protective equipment. If you are unsure about any aspect of electrical work, consult with a qualified electrical professional. Electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements. Regularly review the National Electrical Code and other applicable codes and standards to ensure that your electrical knowledge is current. Continuing education is essential for electrical professionals to maintain their skills and knowledge. Attend training courses and seminars to learn about the latest advancements in electrical technology and safety practices. By staying informed and following safe work practices, you can help to prevent electrical accidents and ensure the safety of yourself and others. The proper application of the National Electrical Code is essential for ensuring the safety and reliability of electrical systems. Take the time to learn the code and apply it correctly. Your efforts will help to make our communities safer and more electrically sound.